Express each number as a product of its prime factors. So 140. 2, then it's 35, then 5, 7. So 140 is equal to 2 square into 5 into 7. Okay. Next question is 156. Here 7, 8, 2, 3, 9, 3, 1, 3. So 156 is equal to 2 square into 3 into 13. Next question is 3825. 3825. With can we do with 3? 3 plus 8, 11. 11 plus 2, 13. 13 plus 5, 18. So 18 is divisible by 3. That implies this can be divided by 3. 3, 1. In 8, 3 is 2. 22, 7 and 15, 5. 3. 4, 2, 5. Now 4 plus 2, 6. 6 plus 5, 11. No, now it is 11 is not a factor of 3. So we cannot divide by 3. 5, 8, 5, 5, 1, 7. So 3825 is equal to 3 square into 5 square into 17. Then coming to the next question, 5005. 5005. Five, 1, 0, 0, 1 is equal to 5 into 1, 0, 0, 1. Next question is 7429. 7 plus 4, 11. 11 plus 2, 13. 13 plus 9, 22. Not possible with the 3. Now 4 no, 5 no, 6 no, 7. 7, 42, 0, 42 no, 8 no, 9. 9, 63 and 11. 1, 1, 72, 12, no, 7429. This is a tough question. This is divisible by 70. 7, 4, 2, 9. If we divide it by 17, we will get that 34 and 68, 4. And here it will come as 62. 62 and 17 is 3 times. That is 17, 34, 34, 41, 51. 1, 1, 9. 17 into 7, 49, 4 balance, 119. So we will get that 43, 437. Now is it divisible with the 17? Here 34, 997. 17 into 6 is 42, 4 balance 102. So 90, 7 is not possible. So now we can with the 90, 19, 38, 2 and 5. 57, 57, 19 into 3, 7, 2, 57. So 3, 23. Therefore 7, 4, 2, 9 is equal to 17 into 19 into 23. Okay. Now let's move to the second question. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of two numbers. First one is 26 and 91. This is an important rule in that is given in the textbook. Here we can find that for any two positive integers a and b, HCF of a and b into LCM of a and b is equal to a into b. Find the LCM and HCF. So for 26 and 91. Two 13, 91, 7, 1, 3. So LCM is equal to 26 can be expressed as 2 into 13 and 91 is equal to 7 into 13. So LCM is LCM of two numbers is the product of the greatest power of each prime factor. Greatest power of each prime factor involved in the numbers. So when coming here in this question, for 26 and 91, the prime factors are 2, 13, 7 and 13. So it is said in the LCM definition that it is the greatest of all prime factors. So here we can include 2, 2 into 7 into, and in this 13, which is the greatest? 13. So 2 into 7, 14. 14 into 13. That implies 14 into 13 is 14 into 3, 28, 32, 42, and 14. 281. 182 is the LCM. We have to prove that this, and we have find out the LCM of this 26 and 91. Now we have to find 26 into 91. And now we have to find HCF. Coming to the definition, what is HCF? HCF is the smallest power of each common prime factor in the given numbers. So here it is common. It's a definition that its common prime factors are required. In this 26 and 91, only one number is common, that is 13. So LCM HCF is equal to 13. And now we have to prove that LCM into HCF is equal to product of two numbers. So here LCM into HCF, that is LCM is 182 into HCF. HCF is 13 is equal to product of two numbers, that is 26 into 91. 182 into 13. 6 4 2 5 4 6 2 1 2 8 1 6 6 13 1 balance 2 2 3 6 6 is equal to, now we have to find out 26 into 91. Into 91, 6 2 54 5 balance 2 into 19 23 6 6 3 2 3 6 6. So proved. For the first question we have find the answer. Now going to the second question, 510 and 92. 510 and 92. 510 92. For 510, 2 2 5 5. Now 3 8 5 5 1 7. So 510 is equal to 2 into 3 into 5 into 17. And for 92, 2 4 6 2 23. 92 equal to 2 square into 23. So LCM, we have seen the definition that LCM is the greatest of all prime factors. So we are here we can see that the greatest of all prime factors. here in 2 and 2 square, the greatest is 2 square, therefore 2 square into, then balance 3 into 5 into 17 into 23, and HCF, it's the lowest of all the common prime factors. Here only one common factor, that is 2 and 2 square. So it is lowest, therefore HCF is equal to 2. Now here we have how to calculate LCM. LCM is equal to 2 square. 2 square is 4. 4 into 3 12. 12 into 5 60. 60 into 17. 6 into 17. 17 into 6 42. 4 balance 6 10. 1020 into 23. 102 into 23. 603 402. 6432. 23460. Now we can look for the product of these two numbers. 510 into 92. Here 2 10 9 45 2 9 6 4 0. 102 9 45 2 sorry here 2 9 6 4 6 9 2 0. Okay, here we get the product of two numbers. Now we have to multiply this LCM into HCF. LCM into 2, 23460 into 2, that will be 46920. Therefore we can say that LCM into HCF is equal to product of two numbers. Coming to the next question, 336 and 54. One 6 8 2 8 4 2 4 2 2 21 and 2 3 7 and 54. To 27. Then coming to 3 9 3 3. So 336 is equal to 2 raised to 4 into 3 into 7, whereas 54 is equal to 2 into 3 cube. LCM is the greatest. Here we can see that what is the full form of LCM? Lowest common multiple. But here lowest common multiple, so we have to take the opposite of that, that is highest in all prime numbers. We have to include all the prime factors of both the numbers. So here it will be 2 raised to 4 is the highest value, 2 raised to 4 into 3 into 7 into, sorry, here 3 and 3 raised to 3 is there, so we have to write the highest value, 3 raised to 3 into 7, 2 raised to 4 2 4 8 16 into 3 raised to 3 3 9 9 to 3 27 into 7 is equal to 16 into 27. 432 into 7. 3024. And HCF. HCF is lowest. HCF, the full form of HCF is highest common factor. You have to take lowest value of common prime factors. Here the lowest is 2 raised to 4 and 2. The lowest is 2. And in 3 into 3 and 3 raised to 3, the lowest is 3. 2 into 3, 6 is the HCF. So LCM into HCF is equal to 3024 into 6 equal to 24, 2 balance, 12, 14, 1 balance, 1, 6, 18, 18, 144. And we have to take the products of two numbers, that is 336 into 54. 336 into 54. For 2 balance, 12, 14, 1 balance, 12, 30, 30, 3 balance, 3 into 5, 15, 18, 1 balance, 15, 16, 4, 4, 1, 1, 8, 1, 1, 8, 1, 4, 4. Here also 18144. 336 into 54 also 18144. So we have proved that LHS is equal to RHS. So we have done the 14th question also. Now coming to the next. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay. 12, 15, 21. 12, 15, 21. 12 is equal to 2 into 3 into 2, and 15 is equal to 3 into 5, and 21 equal to 3 into 7. So LCM is the greatest of all factors. Here we have 3 as common, so the greatest is 3 itself. 3 into 2 into, here it is 2 square, 2 into 2, 2 square, so 2 square into 5 into 7. So 3 into 4, 12, 12 into 5 into 7, 60 into 7, 420. Then coming to HCF. HCF is the lowest of all the common prime factors. Here common factor is only one, that is 3. In that 3 itself, the lowest is 3 itself. So HCF is 3. Okay. Then coming to the next question, 17, 23 and 29. 17, 23 and 29. These numbers doesn't have any other prime factors. So we can say that they are coprime because they only has 1 and that number itself as the factors. So coming to LCM, LCM is equal to 17 into 23 into 29. That is 17 into 23. 21, 2 balance, 5, 14, 1 balance, 3. 1, 9, 3. 3, 9, 1 into 29. 9, 81, 8. 3 into 9, 27, 35. 2, 18, 1 balance, 7. 9, 3, 13, 11. 1, 1, 3, 3, 9. And HCF is highest common factor is the HCF of all coprime numbers will be 1. Here the HCF is 1 because the numbers doesn't have any other common prime factors. So we can say that HCF is 1. Next question, 8, 9, 25. 8, 9 and 25. 8, 9, 25. 8, 2, 4, 2, 2, 9, 3, 3, 25, 5, 5. So 8 is equal to 2 cube and 9 is equal to 3 cube and 25 is equal to 5 cube. Sorry, 5 square. So LCM is equal to 2 cube into 3, here also 3 square, 3 square into 5 square, that is 8 into 9 into 25. 8 into 9, 72 into 25, that is 72 into 25, 360 and 144, 0, 1 balance, 8, 1800, 1800 is LCM. And HCF, there is no common factors. HCF is 1. Next question, given that HCF of 306 and 657 is equal to 9, find LCM of 306 and 657. We have studied the rule that LCM of two number into HCF of that two numbers is equal to product of that two numbers. So we can say that 306 into 657 equal to HCF is 9 into LCM. So this coming 9 to here, 306 into 657 by 9 is equal to LCM. Here it's 3 102. Here also 1, 2, 1, 9. 102 into 219. 102, 219. 18, 1, 9. 201 and 204. 8, 3, 13, 2, 2. That is 2, 2, 3, 3, 8 is the LCM. Next question. Check whether 6 raised to n can end with the digit 0 for any natural number n. We can check it roughly. For any number 6 raised to n, the repeated patterns will come as 6. 6 square is 36, and also 36 into 6 is 216. Similarly, all the squares of 6 will end with 6 itself. So there is no digit 0 will come at the unit place for such 6 raised to n number. But you have to, in board exam, if you have to get mark, then you have to write in specific way. For example, you have to first say that for any number 6 raised to n where n is a natural number, to end with digit 0 should be divisible by 5. That means prime factorization of 6 raised to n should contain 5. But this is not possible as 6 raised to n is equal to 2 into 3 the whole raised to n. The prime factorization of 6 raised to n does not contain 5. We have similarly done a question in the example 1. Consider the numbers 4 raised to n where n is a natural number. Check whether there is any value of n for which 4 raised to n digit ends with the digit 0. This is also the same format as that given in the exercise question. Here first it is said that if the number 4 raised to n for any n were to end with the digit 0, then it will be divisible by 5. That is the prime factorization of 4 raised to n would contain the prime 5. This is not possible because 4 raised to n is equal to 2 raised to 2n, or 2 into 2 raised to n. So the only prime in the factorization of 4 raised to n is 2. So the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 4 raised to n. So there is no natural number n for which 4 raised to n ends with the digit 0. We have to do this 6 raised to n also in the same format. Here only, instead of 4 raised to n, we have to give 6 raised to n, and here also 6 raised to n is equal to 2 into 3 the whole raised to n, whole raised to n. Here you have to substitute this with this equation. 6 raised to n is equal to 2 into 3 raised to n, and instead of all 4 raised to n, you have to substitute it with the 6 raised to n. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Here we can do this as 7 into 11 into 13 into 13. Plus 13 is equal to 7 into 11, 77. 77 into 13, 13 into 77, 21, 2 balance, 91, 91, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1 plus 13. What are composite numbers? Okay. If it can be expressed as the product of primes, then we can say that it is a composite number. So let's do it in another way. Here 7 into 11 into 13 plus 13 is equal to 7 into 11 into 1. Plus, sorry, here we can do that. 7 into 11 is 77 into 13 plus 13, that is, when taking 13 as common, 13 is common, 1 plus 78. 77 into 13 plus 13 is equal to 13 taking common, 77 plus 1, that is 13 into 78. This 13 into, when taking factorization of 78, 2, 39, 3, 1, 3, 2 into 3 into 13. So we can express this number as a product of primes. So we can say that this is a composite number. And in the same case here, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. 7 into 6 is 42. 42 into 4 is 160. Sorry, 7 into 6, 42. 42 into 4 is 168. 168 into 6. No need, 168. So 168 into, here we can write it as 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 equal to 42 for 42 for 168. 168 into 3 into 2 into 5 plus 5. Taking 5 as common, 168 into 3 into 2 plus 1. 5 into 168 into 6. 1009. So 1009 also have no other factors. Here we can write this number as 5 into 1009. So it can also be expressed as the product of primes. So we can say that 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is also a composite number. And coming to the last question. Is it the last question? Yes. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Here the required number of minutes is the LCM of these two time. there is a circular path around a sports field. Sonia when she starts from here and goes and complete this rotation, she total 18 minutes to drive one round of the field, while Devi takes 12 minutes for the same. While Devi same path from here to here, he completes the rotation in 12 minutes. Suppose they both start at the same time and go in the same direction, after how many minutes will they meet again at the starting point? So we have to find out the LCM of these two numbers. Because when we think it in one way, here Sonia moves and complete. Let's take the case of Sonia. Sonia complete one revolution and gets here at 18 minutes. Then she will complete the next rotation 36 minutes. Then next rotation again into 18 into 3, that is 54. Then next rotation 72 minutes. In the same time, Ravi, first he will take 12 minutes, then next rotation he will take total 24, then 36, then 48. So we can say that this is the factors are getting multiplied, that is 18 into 1, 18 into 2, 18 into 3, here 12 into 1, 12 into 2, 12 into 3, similarly it is going. So we have to find when these two times will be same, time will take same time. So we have to find the LCM of these two numbers. Here 18 LCM is 2, 9, 3, 3, that is 2 into 3 square, and 12 LCM 2, 6, 2, 3, that is 2 square into 3. So LCM is 2 square into 3 square, that is 2 into 2, 4, 4 into 3, 4 into 9, 36. Here we see that Sonia has completed the 2 rounds in 36, while Ravi, when he completes the third round, he will reach 36 minutes. That means that at the 36 minute, total taking time is 36 minutes. So at the 36 minutes, Sonia will and Devi will be here. So we can say that both Sonia and Devi will meet again at the starting point after 36 minutes. Both Devi and Sonia will meet at the starting point after 36 minutes. Okay. So we have completed the full exercise 1.1. Also we have gone through the two definitions, that is HCF of the two numbers and LCM of two numbers. HCF of two numbers is the smallest power of each common prime factor in the numbers, and LCM is the product of greatest power of each prime factor involved in the numbers. Also we have seen that for any two positive integers a and b, HCF of a and b into LCM of a and b is equal to the product of the two numbers a and b. So we can use this result to find the LCM of two positive integers if we have already found the HCF of the two positive integers. So now let's take a break.